Hello guys, in today's video, we will learn about how to convert an raster data into vector data and how we can visualize them. So this is the next video in the playlist for the Google Earth Engine for the beginners. So let's start by importing our satellite data. So we are using as usual our Sentinel-2 data level 2A multispectral instrument. So this is of 10-meter resolution. So why I'm using every time the Sentinel data is that this is the data which is available of at highest spatial resolution of 10 meters. So rest are all we have the Landsat for 30-meter resolution, and if you want better resolutions than 10-meter, they're all paid. So the best available for the open source and free data is our Sentinel data. So we will also create a region of interest now for our convenience. So uncheck this geometry for the region of interest and import it as a feature collection. So click on the OK. So now let's start by creating a variable image and select the Sentinel-2 data and filter it to bounds and also filter it to date. Let's filter to the latest from January of this year to October, and also filter our metadata for filtering the cloud cover. So we're using the function filter metadata. Go to the image properties and copy this cloud pixel percentage. So it's a string, and give the variables less than arguments, sorry, and let it be less than 1%, and let's have the median of these images. And let's clip to our region of interest using the function clip to RI. Okay, so let's add this image to our geometry. So leave the visualization parameters as default, and you say it's a two color composite. We'll change the band combinations in the layers panel. So click on the run. Layer is loading. So if you can just give the band combinations for the RGB to be true color composite, we are using 4, 3 and 2 band. So stretch this to 100% and click on the apply. So yeah, our true color composite has been displaying now. So we have seen this in detail in the previous video. So for more color combinations and composites, you can watch my previous video on the true color and false color composites. So let's now derive an NDVI in order to convert this raster into vector. So we are converting our NDVI into a vector layer. So let's start. So take this image and use the function normalized difference. Okay, and open the square bracket in order to have the bands in the list, and use the near infrared band and red band, and you can rename this layer as NDVI. And next we are going to create a vector layer now. So let's say our variable name is vector, and take the raster of our interest, which has to be converted into vector. So we are converting the NDVI layer here, and you can use the function reduce to vectors. Yeah, so reduce to vector function is used. Again, click on the control plus space button. You will get the requirements which is needed by this function in order to run. So open the flower bracket for giving the for to be it in a dictionary. So reducer we have to use is the ee dot reducer dot say count every, because I want to count every pixel that is in the NDVI layer. Okay, so count every is there. Next is that uh, give the geometry our region of interest, and the scale must be 10, which is the resolution of our image. So let's restore our geometry type with this 8 connected. Label properties, CRS transformations are not needed. So you can have the best effort to be say true in order to run the function properly, and you can also give the max pixel value to be let's say 1 raised to the power 9, and the style scale and geometry native projection and all not needed. So just close our brackets, and you can click on the run. So before clicking on the run, let's add our NDVI to the layer in order to have the better visualization of our raster data. Leave the visualization parameters as default, and let's claim it as a raster. So click on the run now. So you can uncheck this true color composite because it's of no interest to us. So yeah, our NDVI layer has been loaded now as raster. So extend the stretch the range to 100%. So its value is from 0.03 to 0.7. Click on the apply. Yeah. So you can use the color palette if you want. If not needed, then we can go ahead. Then now we are adding our vector layer to the map. So map.add layer vector. So leave the visualization parameters as default and name it as say vector. So let's give the run. So yeah, we are getting an error because our raster data should be an integral type. So let's convert our NDVI data into thresholded image. Let's rename it as a raster. Okay, and take our NDVI layer and have the values which are greater than zero point 0.5. So this will create an binary classification as I have showed in the earlier videos. So values which are greater than the zero point 0.5 will be assigned for the value of 1, and values and the pixels which are having the value less than zero point 0.5 will get the value of 0. So like this, let's use this as a raster. So let's add our raster to the map layer, and also change our raster input in the vector layer to be raster, and it has been reduced to vectors. So geometry count every. Okay, everything is done now. So now click on the run. Our two layer is loading, say raster and vector. So this is our raster layer which has been classified into a binary classification where the points which are greater than 0 0.5 have been assigned the value of 1. You can use the inspector column. So yeah, here you can see our raster NDVI is 0. So if you click on the white section, you will get the value of 1. So this raster dataset has been now converted into vector. You can uncheck this geometry. So here you can clearly see uh, the black and white data which has been converted into vectors. So slightly move up and down in order to compare the raster and vector. So yeah. So you can adjust the transparency to check whether the rasters have been converted or not. So that's it guys for today. Thank you for watching. So if you have any kind of queries, you can comment on the comment section. Thank you.